Hello and welcome to our webinar, our last webinar on translations. This is dilations and reflections. This unit is to be watched before May 5th for the class period. And so what we are going to do is we need to write an equation of x squared where the graph is translated up 3 units and to the left 5. So we'll start out by saying, well, y equals x squared. That would be our parent function. And if I'm going to move it up 3 units, we have to remember, is this inside or outside the function? If it's outside the function, it's up or down. And how do we make it move up? Well, that is plus 3. So there it is. That's if just the graph was translated 3 up. So then we have to remember, what does it mean to move to the left? Well, the left is -5 on the number line. But remember, when we put it inside the function, because left and right is inside the function, inside the square, we end up with the function being the opposite of what we see there. So when I write this, I'm going to write my squared outside, add my plus 3 because that's up 3, and it's going to be x plus 5 because the opposite of what we see, -5, would move it to the left 5 and up 3. So that would be my equation that I'm looking for. And so that's the type of things that we've been doing in the past. So now we're going to move on and we're going to take these parent functions and we're going to graph the parent function, and then we're going to go ahead and see what happens when we do all of these translations to it. So I want you guys to try this on your own, and then I'm going to move on to the graph on the next page. So I would set up a t-table, x equals y, and I'll do that on the next page and go through. So the first one, I want you to multiply all the x values by 1/2. Then I want you to multiply all the y values by, or the x values by 3, and then all the y values by -1. See what happens to the graph. Well, what happens is this. When we get these are the equations that we would get. So if I have my parent function, y equals x, I would get whatever I put in for x, I'm going to get back for y. And so I get this nice straight line, looks like this. That would be my parent function. And so there it is. There's my parent function. So the question is, what do these other graphs have to do it? So if I multiply all my y values that I got by 1/2, it's the same as taking the x values and multiplying by 1/2 also. So for the equation y equals 1/2 x, if I choose the same x values, I will get -1, 0, and 1. And -1 cut in half would be -1/2. I know you don't like dealing with fractions, but we're going to have to. And then we're going to get a positive 1/2 down here when I plug the x values into the equation and solve for y. So in this case, I would get a graph that would go through the center again, but it would probably look a little more like that. And so what happens is that when I multiply by 1/2, the graph isn't quite as steep. It's about half as steep. The slope of the graph, remember that the number in front of x is the slope, and so I'm going up 1 for every 2 that I go over. And so that's what makes this graph. Now, if I multiply it by 3, that would think that was the next one they said, so we'll use that one next. And so x, y, and if we're using y equals 3x, whatever I put in for x, I'm going to multiply it by 3. So I get -3, 0, and +3. So I'll plug those in. So when I'm at -1, I'm down 3. +1, I'm at 0, and I'm at +3. So I'll get a graph that looks something like this. And so probably something fairly steep like that, and I missed by a little bit. So we can adjust that a little bit to make the graph go through the points I want. So you can see how steep the graph is. It's a lot steeper than it was before. So multiplying by a number bigger than 1 will make the graph get steeper. Multiplying by a number less than 1, between 0 and 1, will make the graph get flatter. And so finally, what happens if I multiply the graph by -1, which is really what we're saying there. And so I would set this up as my x and y. And you guys have done this on another paper. So it just switches the sign. So I get +1, 0, and -1. So at -1, I'm at +1. At 0, I'm still at 0. And then down here, so I end up with a line that is in the complete opposite direction of our original line. And so when we multiply by a -1, that flips the graph over and changes the direction of it. So that is what we'd call a rotation. The other ones are dilations, because you're multiplying by numbers between 0 and whatever. So then again, does this have the same effect if I do it with x squared? Well, it should, because all graphs have the same translations. Let's see what happens when we do it with x squared. So here's my graph again, and so we'll go through and do all of our graphs on the same one. And so we end up with, if I do y equals x squared, my parent function, we've seen this enough times that you probably don't need to set up the t-table, but I'm going to set it up anyway. If I square 1, I get -1, I get 0 and +1, so I get points that look like this. And I know this is a U-shaped graph, so I'm not going to plot anymore. I'm just going to make a U. Looks like this, going through those points, hoping that I get pretty close. Well, the next one, when I multiply by a half, what do you think is going to happen to it? Well, in the previous one, when we multiplied by a half, the graph flattened out. So do you think that will be the same thing that's going to happen here? Well, if I put -1, 0, and 1, order of operations say square the number first, then multiply it by the half. So if I square -1, I get +1, and then I cut it in half, I get a half. 0 is still 0, and if I put 1 in there, I get 1/2 again. So I'm here at 0, 0, then I'm out here at a half. And so you can see that, yes, I'm still going to get the same U-shaped graph, but it's going to get flatter. What if I chose something like 2? Let's say I put 2 in and -2 just to see where I'm at. If I put -2 in, I get 4. 4 cut in half is 2. -2 would also be 2. So at 4 over, at 2 over 1, 2, I should be 2 up. So it should be something like this. It's not as flat as I made it out to be. But so this graph, the blue graph, should be here 2 over 2 up, something like this. It's not the same graph. Oops, I missed it again. It should flatten out. Let's see if I can hit. There we go. I hit it that time. My lines are a little crooked, but it should kind of flatten out and go, basically the same thing. But when we multiply by a function between 0 and 1, the function is going to flatten out. If I multiply by 3, well, what do you think that's going to do to the graph? Well, I'm going to choose the same x values as I always choose. And so I'm going to, again, plug this in. -1 squared is 1, and then I multiply it by 3. 0 is 0, and 1 squared is 1, times 3 is 3, and I'm just following my order of operations. So at 0, 0, I'm still at the same point. I didn't move it. There's no adding or subtracting, so I didn't move it left or right. If I go to -1, I'm up 3, and if I'm at +1, I'm up 3. So you can see that when I multiply by a number bigger than 1, the graph gets narrower. And so then what do you think is going to happen when we multiply by a -1? If I make it y equals -1x squared, well, if I set that up, it's not just going to change the signs, but we'll see what happens here. Should be the same, since it's x squared, it should be the same U-shaped graph. It just depends on what direction it's going. If I put -1 in, I get +1 when I square it, but then I multiply it by a negative, so I get a negative. 0 is 0, and 1 squared is 1, times -1 is -1. So it looks like at -1 I'm at -1, at 0 I'm at 0, and at +1 I'm at -1. So my graph doesn't open up anymore. It's the same as the black graph, it's just opening down. So again, this time we flipped it over, and that's what happened before. We flipped over, when we multiplied by a negative, we flip it over. So remember, multiplying by a negative flips it over, multiplying by a number less than 1, between 0 and 1, flattens it out, and a number bigger than 1 will make it narrower. So do you think this has the same effect if it is a square root function? Well, let's find out. Again, we're asking you the same questions to multiply by a half, multiply by 3, and multiply by -1. So we'll move on to the equation page. So we'll start with our parent function again. Y equals the square root of x. And when we graph that, I end up with, well, remember, be wise. I'm not going to pick negative numbers because that's not going to be a negative number. You can't take the square root of a negative number. And so this time I'm going to plug in 1. and I'm going to pick perfect squares, 4 and 9, because I know I can get those on my page when I take, and can I do, now 16 won't fit, so I'm not going to do it. Oh, and 0, I could put squeak 0 in up there. I'll put 0 down here. So if I put 1 in, the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and the square root of 0 is 0. So at 0, 0, I'm here at this point. At 1, I'm at 1. At 4, I'm at 2. And at 9, I'm at 3. So I get a square root function, and this is the parent function. This is the function that all of them will look like, except for if I was adding or subtracting, I would be moving it left or right, or up or down, and it would look exactly the same. But this time I'm doing some multiplying. So this time when I do y equals 1/2 the square root of x, again, be wise about your numbers. The square root is outside the square, this 1/2 is outside the square root, so be wise about the numbers you choose and pick numbers that you can take the square root of again. So when I do this, I'm going to pick the same numbers I picked before, 0, 1, 4, and 9. When I pick those numbers and plug them in, square root of 0 is 0, cut it in half, still 0. Square root of 1 is 1, half of that is a half. Square root of 4 is 2, I take that in half, I get 1. And the square root of 9 is 3, and a half of that would be either 3 over 2 or 1.5. Now, I'm going to have to estimate approximately where some of these numbers are, like the half and the 1.5. So I'll put 0 in here. And the question is, by multiplying by a half, did I squish this graph? Did it flatten out? Did it get a lot less steep than this one before? If I put 1 in, I'm at a half, which is right here. If I put 4 in, I'm at 1. If I put 9 in, I'm at 1.5. And you can see the answer to this is yes. We end up with a less steep graph, and it's a little bit flatter, but it looks the same. It starts at the same point. It's not moved up, down, left, or right, because we're not adding. We're only multiplying. So then the next one, if we do y equals 3x, y equals 3 times the square root of x, then I'm going to still pick the same numbers because I still have to deal with the square root. And so I've got 0, 1, 4, and 9. Because these are perfect squares that I can take the square root of without getting decimals. Putting 0 in, I get 0. Putting 1 in, I get 1 times 3, which is 3. Putting 4 in, square root of 4 is 2, times 3 is 6. And then plugging 3 in, or 9 in, square root of 9 is 3, so 3 times 3 is 9. So before, when we multiplied by a half, the graph flattened out. When we multiplied by a number bigger than 3, it got kind of stretched, it got kind of bigger, taller, and that should be what happens with this one. So 0, 0 remains the same. 1 over, this time I'm up 3. And 4 over, I'm up to 6. So there's 2, 3, 4, 5, 6. And when I'm at 9 over, I'm up to 9. And you can see that multiplying by a number bigger than 1 really stretches this graph out and pulls it way up. And so when we multiply big numbers bigger than 1, pulls it up. Multiplying by half kind of flattens it out. What do you think is going to happen when we multiply by the negative square root of x, or multiply by a negative 1? Well, if history repeats itself, then we should end up with the same value. We should have the same graph as the black one, but upside down. That's what history has told us from the previous two ones. So I'm going to pick the same values because I still have to take the square root, and I want perfect squares. Makes my life easier. Square root of 0 is 0 times negative 1 is still 0. Square root of 1 is 1 times negative 1 is now negative 1. Square root of 4 is 2. 2 times negative 1 is negative 2. And square root of 9 is 3 times negative 1 is negative 3. So history is going to repeat itself, that if we multiply by a negative, this graph is going to be basically the same as the black one, but upside down. And so let's see if I can sketch this. Something like that. And so the black and the green are the same, except they're flipped over the x-axis. So when we multiply by a negative 1, the graph gets flipped over the x-axis. Multiply by a number bigger than 3, it gets stretched out, gets bigger. When it's multiplied by a fraction, it gets flattened out, and it's the parent function.